Okay. So your bounded input and bounded output stability concept we are understanding. So here for every bounded input means what? It is a finite quantity. Okay, and it is bounded to some particular time. So in that particular input, if you take, so bounded output will be generated. Okay, that is what exactly the concept here. Okay, so this you need not to worry about anything. Okay, so I will just go for this particular criteria. Okay, so this is nothing to do with bounded input and all. Okay, so once we understand this particular concept for the sake of your internals point of today. Okay, so later we can go for I will just brief out what are the things to be studied. Okay, later. Clear. So now take the heading RH criterion, Routh-Hurwitz criterion. Okay, all of you follow carefully. Okay, Routh-Hurwitz criterion. So here let us consider. So this is one of the stability criteria. Okay, so Routh-Hurwitz criteria is a stability criteria. So where you can find out the stability out of it. Okay, so what is the procedure and all we will discuss now. Okay, how the Routh-Hurwitz criteria to be used. Okay, all those things we will discuss. Take the heading Routh-Hurwitz criteria. So now let us consider a negative feedback control system. Let us consider a negative feedback control system characterized by following characteristic equation. 1 plus g of s into h of s is equal to 1 plus g of s into h of s is equal to a naught into s to the power of n plus a1 into s to the power of n minus 1 plus a2 into s to the power of n minus 2 plus etc. an. Okay, etc. an. So n minus s to the power of n minus n is 0. S to the power of 0 equal to what? 1. That is why at the end we can write it as an. Okay, an equal to 0. So 1 plus g of s into h of s is equal to a naught into s to the power of n plus a1 into s to the power of n minus 1 plus a2 into s to the power of n minus 2 plus etc. up to an s to the power of n minus n. N minus n is 0. That is why s to the power of 0 equal to 1. So an equal to 0. So that is what is required. So let us assume that coefficient of various powers of s. Let us assume that. So take this particular thing. Let us assume that coefficients of various powers of s in the above equation are positive. So why? Because while deriving the generalized things, we don't take negative and all. Okay, so we will take positive only. Okay, so let us assume that the coefficient of all various powers of s in the above equation are positive. Okay, so now according to the RH criteria array, the above equation can be put in the form of an array as indicated below. Okay, so what is this particular indication we can do? You can see here the first column. Okay, so make this particular first this one. Okay, line, vertical line, and this horizontal line. Okay, horizontal line and vertical line, you need to write it. So just put the first row as s to the power of n. Okay, put the first row as what? S to the power of n. The second row as s to the power of n minus 1. Second row as s to the power of n minus 1. Is that clear? So once you written this one, okay. Now start from the A naught. You see here, what is the maximum? What is the what is the largest power of S is S to the power of n in this equation. What is the coefficient of largest power of S? It is A naught. Okay, it is what? A naught. You take it. Okay, take A naught. Okay, after that, leave the next power. Okay, alternatively, leave the next power coefficient, that is A1 you need to leave. Next you go for A2. Okay, next to go for A2. So like that you are going to write in the A2. So next you leave the another one, you go for next one, that is A4. Next leave one, another one, go for A6. Next go for A8. Keep on going like this. Okay, this is the procedure of RH criteria, how to find out the stability I am telling. Okay, so now take the next column as, next row as S to the power of n minus 1. Okay, here S to the power of n minus 1 we are going to take. Okay, next power. Next, you take the coefficient of this one, S to the power of n minus 1 is A1. Okay, take A1. Next, you take A3 because leave another one because A2 is already taken here. Take A3. Next, go for A5. Next, go for A7. Next, go for A9, etc. So these two rows, you need to write it mandatorily. Taken?
Yes, sir.
So once you've taken this one, okay. So now we need to calculate the this particular B coefficients. Okay, B1, B2, B3, B4, like this we need to calculate. Okay. So next column is for C1, C2, C3. We need to calculate. Okay. So in most of the numericals, so I have seen that only 1, 2, 3. Okay, up to A0, A2, A4, up to A1, A3, A5, B1, B2. C1 maximum another one will come. Okay, up to 4 to 5 stages it will come. After that it will not going to come. Okay, so but as a procedure we need to understand that how it is being done. Okay, how it is being written. So let us consider B1. So when B1 has to be found out, okay, how to find out the B1? You need to multiply like this. Okay, A1 into A2 minus A naught into A3, that is cross multiplication, divided by A1, divided by A1. Why A1? Because it is above the B1. So whatever the content which is above the B1, we need to take it. When we are finding the B2, so once again we need to take the A1 only. See here, A1 is the first, this one. Okay, so this is the base. Okay, this will be the denominator. Okay, so like this, we have to take the B1 value. So A1 minus A2 minus A0 minus A3 divided by A1. Similarly, when we are talking about the B2, how to find out B2? Very simple. So once again, A1 minus A4, sorry, A1 into A4 minus A0 into A3. Okay, this first A0 A1 row is there, column is there. Now this will be acting as a base. So here A1 is the base element we have taken. See, you can see that B2 equal to A1 A4 minus A0 A5 divided by A1. Similarly, B3, that is A1 A6 minus A0 A7 divided by A1. Similarly, B4, that is A1 A8 minus A0 A9 divided by A1. Clear? So like this, you need to multiply and we need to form the B terms. One particular row you are going to calculate. Can you able to understand this one? Any doubts? Can you able to? Any doubt in this particular row formation? All of you?
No, sir.
No, sir. So next is what? Similarly, we are going to find out the C1, C2, C3, C4. How to find out C1, C2? Similar way. See, C1 will be equal to what? B1 into A3 minus A1 into B2 divided by the base is what? B1. Okay, you can see that B1 into A3 minus A1 into B2 divided by B1. Similarly, C2 value how to find out? So it is very simple. So take this row, so this column and this column. So here B1 into A5 minus A1 into B3 divided by B1. Okay, like this we are going to do it. Okay, like this we are going to cross multiply and considering the first element above the consideration will be the base denominator. Okay, so copy this one. Similarly, how we are going to find out this one? Please write this one, all of you. So once you've taken this one, please let me know. So similarly, it will keep on moving. Okay. So at the end, okay, at one point of stage, what will happen is there are some elements will be missing. So the value will not arise. Okay. So it will get end within 2 to 3 steps. Okay. So this is the RH criteria array. How to calculate the coefficient values. Is it clear?
Yes, sir.
So now here one thing is that after calculation of all these things, how to find out whether the system is stable or not. Okay, that is what the question here. So you make sure that you write down all the coefficients in the characteristic equation are considered to be or assumed to be positive numbers. Okay. So if there are negative and 0, okay, the system is said to be either unstable or marginally stable. So by seeing the equation itself, by seeing the characteristic equation itself, we can able to understand one thing that, okay, so what I can understand, we can understand that all the coefficients are positive. So if there are some negative numbers are already there in this particular equation, then we can say that the system is unstable. Okay, or else we can say that it is a marginally stable. That means what? It is neither stable nor unstable. It is about to stable. That means what? There are some conditions, then only it is stable. If the condition is not there, it will be unstable. That is what exactly the concept here. Okay, all the coefficients of characteristic equation are assumed to be positive numbers. If there are negative and 0, then the system is either unstable or marginally stable. This is one of the condition. This is one of the conclusion also I can say. Okay, so this is a note. Okay, in the characteristic equation. Now we are going to see the condition what happens in the array, in the RH array. Is it clear? So after taking
Yes,
this
sir.
one, I can take, yeah, after taking this one, I can take like this, the number of sign changes here. You can write this particular thing. Okay. The number of sign changes in the first column of the Rx array indicates the number of roots of the characteristic equation, okay, that lie on the right hand side of the S plane. So if there are two sign changes, that means what? See what happens, you know. So here, yeah, I'll explain from the array. So this is the first column of the array, correct? So if A0 is positive, A1 is positive, B1 is negative, C1 is positive, and the remaining all are positive. How many sign changes are there? I repeat, if A0 is positive, A1 is positive, B1 is negative, C1 is positive, and remaining all are positive. How many sign changes are there?
Only one, sir.
Yeah, you are telling that it is 1, but it is 2. How it is 2? Because see, A0 is positive. So next line is what? Positive. Positive to positive, there is no sign change. Yes or no? Some positive to negative, there is a one sign change.
Yes, sir.
So from negative to once again positive, another sign change.
Yes, sir.
So two sign changes are there, correct?
Yes, sir.
In a column wise, we are talking about. You are telling that how many sign which is odd man out, like that you are telling. Okay, for a coefficient value. I am telling that in a column, how many sign changes are present. Okay, that is the difference. Is that clear?
Yes, sir.
That one we are discussing here. The number of sign changes in the first column of the RH array indicates that the number of roots of the characteristic equation that lie on the right hand side of the S plane. So next is what? Hence for closed loop stability, okay, it is necessary and sufficient that, okay, see, if the roots are lying on the right hand side, so system will be what? Unstable. Okay, so in the earlier classes, I think I told you that if all the roots are lying on the left hand side, okay, then it is stable. Okay, if the roots are lying on the right hand side, the system is said to be unstable. If any one of the one or two roots, one root is lying on the right hand side also, system is what? Unstable. Okay, so if the root is, if out of 3 to 4 roots, all roots are in left hand side and only one or two roots on the axis, okay, on the zero axis, it is called as what? Marginally stable. Okay, so this is the condition. So this particular condition we have discussed earlier also. Yes or no? So while discussing poles and zeros, as I told you that to be a stable system, okay, so all roots should be in left hand side. If the roots are lying on the right hand side, we consider it an unstable system. Is that clear? So now you make a note of it. Okay. So if all roots are lying on the left hand side, system is stable. If any root is lying on the right hand side, system is unstable. If all roots are lying on left hand side and any of the roots are lying on the axis, okay, then it is called as what? Marginally stable. Marginally stable. Is that clear? So once you write on this one, you can write one more thing, that is, hence for a closed loop stability. Closed loop stability in what? In order to get the system stable. So it is necessary and sufficient that no sign change should happen. So if no sign change is there, means what? No root is lying on the right hand side. If no root is lying on the right hand side, we can say the system is stable. That's all. Hence for closed loop stability, it is necessary and sufficient that no sign change is observed in the first column of the roots array. Take on this one. Please take this one. Taken all of you?
Yes, sir.
So is it clear? Is it clear how to form the RH
Yes, sir.
array? Yeah, somebody is asking doubt. Please tell me. Please tell me. Somebody is asking some doubt. Some girl, I think so. Voice came.
Sir, my mother, sir, by mistake she took.
No problem. No problem. So now this is the condition. Okay. So now there are some limitations of RH criteria also. Okay. So what are the particular limitations? We'll see. Write the first one. Limitations of RH criteria. So it does not give the location of root C. We told that how many sign changes are there, that many roots will be available on the right hand side. We didn't tell that where exactly the roots are there, correct? The value of the roots and all we didn't discuss. So that means what? RH criteria does not give the location of root that lie on the right hand side of the S plane. That is the first limitation. Clear? The second, it does not tell whether the root that it does not tell whether the roots that lie on the right hand side of a plane are real roots or complex roots. See, when they are not telling the value, when we are not able to find out the value, if we were trying to find out the value, then only we'll come to know that whether the complex number will come or normal number will come. So that is why I can say that. So it does not tell whether all roots that lie on the right hand side of S plane are real roots or complex roots. That is not able to obtain. That we cannot able to find out. That is also one of the limitation. Okay, and the next thing is what roots criteria cannot be used for investigating stability of the digital system. Okay, roots criteria cannot be used for investigating the stability of the digital system. Is it clear? So digital, we are discussing whatever the discussion we are doing, that is for only the analog. Okay. So for digital, we are not going to discuss anything. That is why I can say that those criteria cannot be used for investigating the stability of the digital system. These are the limitations. These are what? These are the limitations. Taken all of you? You understood?
Yes, sir.
So now next thing is what we will go for the numerical. Okay, how to solve it? Very simple now. So first numerical, please take down all of you. This one. Investigate the stability of a negative feedback control system whose characteristic equation is given by 3s to the power of 4 plus 10s cube plus 5s square plus 5s plus 2 equal to 0. Equal to what? 0. See, I'll give you 1 minute of time. Please write the question. It's very important questions. All of this one.
Sir.
So once you have taken this one, we can go for writing the Rx array. So very simple array. So as I told you, whatever the highest power of S is there, that has to be the first row. Okay, S to the power of 4. So what is the next power? S cube. Take this as S cube here. Okay. So now you take the coefficients. Okay. What is the first coefficient? S to the power of highest power coefficient. This is for 3. So take 3 here. Next skip 1. Go to the S square, that is 5. Take 5 here. Okay. So next skip 1. Go to the next one, that is 2. So go to the 2 here. Taken. Do you have any doubt in this particular values replacement? How we are going to get this particular 3, 5, 2?
Sir, third row A square. That row how you got?
That I will tell. Second row is clear to you. S cube. S cube how to do it? 10 is the coefficient. And another one is what? Skip 1. 5 is the coefficient. There is another one. Nothing is a put a dash. Clear. So now the next row when it comes here, see obviously you see the LH, that is a column, S to the power of 4, S cube. Next is what? S square only we should take. No, S square, S to the power of 1, S naught. So you need not worry about S1 and S naught now. Just take the S square, this one. Okay, row. Why? Because here also we are taken like this only. See. Here S to the power of n, next S to the power of n minus 1, here S to the power of n minus 2, okay, up to S to the power of 0. Okay, so S to the power of n minus n we are taken. Okay, I just made mistake with n minus n I have not written. Okay, similarly here also I am writing this one S square. Now 3.5, how it will come? Very simple. So how to take the multiplication? Cross multiplication. So 10 into 5, okay, minus 3 divided by 10. Clear? That is what I learned, correct? That is what we learned to find out the B1 value, correct?
Sir, can you repeat, sir?
I tell you. So here we are written after taking these 2 columns, okay, 2 rows, we have taken the value B1. Okay, how to find B1 we told? We have to multiply, cross multiplication here, A1 into A2 minus A0 into A3 we have taken. Sir?
ಅವಿನಾಶ್
Sir?
ಯಾವ ಮಾಡ್ಯೂಲ್ ಮಾಡ್ತಾ ಇದ್ರೆ
ಸರ್ ಇದು RS criteria ಮಾಡ್ತಾ ಇದೀನಿ ಸರ್.
ಮಾಡ್ಯೂಲ್ ಯಾವ್ದು ಅವಿನಾಶ್?
ಸರ್ ಮಾಡ್ಯೂಲ್ 4 ಸರ್, M4 ಮಾಡ್ಯೂಲ್ 4.
CO4 ಬರುತ್ತಾ? ಕೋರ್ಸ್ ಔಟ್ಕಮ್ಸ್ 4 ಬರುತ್ತಾ?
ಎಸ್ ಸರ್, CO4 ಬರುತ್ತೆ ಸರ್.
ನಾಲೆಡ್ಜ್ ಲೆವೆಲ್ ಯಾವ್ದು ಬರುತ್ತೆ?
ಸರ್ ನಾಲೆಡ್ಜ್ ಲೆವೆಲ್ K3 ಬರುತ್ತೆ ಸರ್.
ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಹೇಳಿ ಇವಾಗ?
ಸರ್ ಇದು ಡೆರಿವೇಶನ್ ಮಾಡಿ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಮಾಡ್ತಾ ಇದೀನಿ ಸರ್.
ಅನಾಲಿಸಿಸ್ ಅದು K4 ಬರುತ್ತೆ.
K4 ಬರುತ್ತೆ ಸರ್. ಓಕೆ ಸರ್, K4
ಬರುತ್ತೆ. ಅದು ಅದೇನೋ ರೆಕಾರ್ಡಿಂಗ್ ಸೆಷನ್ ರೆಕಾರ್ಡಿಂಗ್ ಹಾಕೊಳ್ಳಿ.
ಸಾಕೊಂಡಿದ್ದೀನಿ ಸರ್, ರೆಕಾರ್ಡಿಂಗ್ ಮಾಡ್ತಾ ಇದೀನಿ ಸರ್.
ಸರಿ ಅವಿನಾಶ್, ಕಂಟಿನ್ಯೂ ಮಾಡಿ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸೊ ಮಚ್.
ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಗುಡ್ ಮಾರ್ನಿಂಗ್.
Good morning, sir.
ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಹೌ ಆರ್ ಯು ಆಲ್?
We are fine, sir.
ಗುಡ್, ವೆರಿ ಗುಡ್ ಅಪ್ಪ. ಪ್ಲೀಸ್ ಕಂಟಿನ್ಯೂ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಅವಿನಾಶ್.
ಓಕೆ ಸರ್.
Fine, sir.
Yeah. So now, dear students, we'll continue. Okay. So now we can see that. Okay. How we written the B1 value? We have taken a cross multiplication, correct? So cross multiplication of what? A1 into A2, we have taken the cross multiplication. Okay. Similarly, A1 minus A2, A1 into A2 minus A0 into A3, we have to take, correct? So divided by what? Base value A1. Okay. Similarly, we have to take this particular numerical also. See here. 10 into 5 minus 3 into 5 divided by 10. Okay. So that is how we are going to understand the thing. Can you able to see? Can you able to do it, all of you?
Yes, sir.
Now it is clear?
Yes, sir.
Okay. So now similarly, how 2 will come? Because 10 into 2, okay, 10 into 2 minus 3 into nothing is means for 0, correct? 10 into 2 divided by 10, how much? 2, yes or no?
Sir, or
Yes,
else
sir.
we can write directly, sir, from leaving
Yeah.
S
See,
code.
from here we can directly write this particular value to here. So you tell me what directly you told without calculation you can directly write, or what you asked?
Yes, sir. 3.5 we will get from S square coefficient, and 2 we will leave S coefficient and write the constant term, sir.
So that is also possible. That is also correct only. Okay. See, don't see coefficient and all. What will happen is from the first row, first two rows, we are getting directly. No. After that, the value is going to be changed. Value will change. Okay. That is why we cannot take the S square coefficient directly. Okay. Hello.
Yes, sir. Yes, sir.
Only first two rows only we can take.
Yes, sir.
First two rows only we can take, but we cannot take. See, all these are calculated values. Okay, all these values are calculated values. Okay, don't take directly. Is it clear? Okay, so you are not supposed to take directly. And what is the next thing is you need to do the multiplication process here. Okay, you have to write this one. So what is the writing you write? You have to write that this particular value sideways to the calculation 10 by 10 into 5 minus 3 into 5 divided by 10. That sideway you need to write it and you have to replace the value equal to 3.5 here. Similarly 2 here. Okay, so I just told you that. See, when you are doing the cross multiplication, it is common thing. Okay, this into 2 you have made. Okay, and remaining cross multiplication, any one of the term is 0. No, at that time, what will happen? 10 into 2 divided by 10 only will do. Correct. So answer is what? 2 you will get. So instead of doing the calculation, if you see that in the cross multiplication concept, okay, if this row is this column is completely given and this column one term is missing, okay, below term is missing. So this is the value. Obviously, this value will come into picture. Okay, that is why again I told you that without calculation directly you can understand and you can write the 2 here. Okay. So similarly, after this particular things are over, no. So we have to go for the next thing. Okay. So when you are going for the next thing, you can see that, okay, 3.5 into 5. Okay, 3.5 into 5 minus 10 into 2 we need to do, correct? 3.5 into 5 divided by 10 into 2 if you do, divided by 3.5. How much will you get? Minus 0.71 you will get, correct?
Yes, sir. Correct.
Yes, sir.
So now the next thing you need to calculate. Why? Because 3 into 0 minus 10 into 0. 0 by anything 0. That is why this term will not come into picture. Correct?
Yes, sir.
So now we are next thing is what? 0.71 into 2 minus 3.5 into 0 divided by minus 0.71. So what is the answer you will get? You will get 2. Check it out.
Yes, sir. Getting, sir.
Correct. So now Here also, since this is not there, you can directly take this 2 here. Okay, that is your understanding, that is your concept. If you don't understand anything, no problem. So you just take this particular things. Okay, cross multiplication only, calculation part only you do and get the value. Correct. Now we only do this particular thing now. So what is the thing you can understand? There is 3, 10, 3.5 minus 0.71. Okay, so it is there no. Okay, so how many sign changes are there in the first column?
2 sign changes.
Two sign changes are there because 3 is positive, positive to positive, positive to positive. Now after 3.5, positive to negative it is changing, from negative to positive it is changing. That is why you can say that two roots are lying on the right hand side. When two roots are lying on the right hand side, the system is unstable. Is it clear?
Yes, sir.
So this is what the numerical we need to do it. Okay, is it clear? Any particular thing if they give also, you can able to do it, right? So instead of 3 into s to the power of 4, I will give you 4 into s to the power of 6 plus 5 into s to the power of 5 plus 12 into s to the power of 4. Like that I will give one equation. Can you able to find out?
Yes, sir.
Same thing, right? It is something like playing a puzzle, correct? Not only puzzle, the same routine we need to follow, correct?
Yes, sir.
Okay. Now, after we understanding this one, okay. So there are some two difficulties which we'll encounter in the what you call for that RH criteria. Okay. What is that particular difficulties we'll see. Okay. So difficulty one, write down all of you. After writing that system in this above roots array, there are two sign changes in the first column. That means for two roots lie on the RHS of S plane, the system is unstable. That you write. After you writing that one, you write this one. Difficulty one. Difficulty one. Difficulty one. Okay, in the difficulty one, in order to understand the difficulty one, we need to take another system. Right on. A negative feedback control system is given by the following characteristic equation. Please write this particular characteristic equation. Keep on solving. You tell me what is the problem you will get. You will only come to know what is the difficulty. Are you solving?
Yes, sir.
Please solve it. When you're solving, you will come to know what is the difficulty. Please tell me that what is the difficulty you will find.
We got infinity.
You got infinity. Very good. Any other got anything? That is correct only.
So the
Any other
number of
got?
values keep on continuing.
No. We will get infinity. Okay. That means what? Those who, the one who told infinity, no. So you might have got 0 here, correct?
Sir, that one is infinity, sir.
This one, how it will come infinity?
Sir, 2 minus 2, 0. 0 by anything, infinity, no, sir.
No. Anything by 0 is infinity. 0 by anything is 0. You got my point?
Sir, we'll get minus 2 by
Yes, sir.
0, sir, which is infinity.
No. I'll tell you one thing. See here. 1 into 2 is 2. 2 minus 2 is 0. 0 by anything is. Huh? Yeah. 0 by anything is 0 or infinity?
0, sir.
0. Anything by 0 is infinity, correct?
Yes, sir. 0.
You might have confused. Okay. So this is the condition you will get, correct? So when you are putting 1, 2, 3 will come, no. So here 1 to 5 will come. So here 0 will come. Correct? The next column is minus 2, it will come. So next thing is what?
Yes, sir.
You will not get anything, correct? So when 0 comes, can you move forward? You cannot move forward, no. Why? Because next is what? 0 into 2. Okay, 1 into minus 2 divided by 0. It will come infinity now. S square will be infinity, correct? So there is no root which is infinity. Okay, for a practical system, there is no root which is infinity, correct? So up to this, when you are the solved, you just write difficulty 1 means write down solution. So when difficulty 1 arises, we need to give a solution row. Write down difficulty 1 means entry in a row is B0. Difficulty 1 means the first entry in a row is 0. First entry in a row is 0. First entry in a row is 0. Okay, to overcome this difficulty, how to overcome this particular difficulty? Put S equal to 1 by Z in the characteristic equation and repeat the roots process. Repeat the roots process. Clear? So that means what? Wherever S is there, you put S equal to 1 by Z and repeat the process. Okay. So now letting S equal to 1 by Z in the characteristic equation, we will get this particular equation. That means 1 by Z whole square to the power of 5 plus 1 by Z into whole to the power of 4 like that. Okay. After that, we cannot take the denominators like 1 by Z and all. No. So what we'll do? We'll multiply with Z to the power of 5 on the above equation completely throughout. Okay. And RHS also and LHS also. So if you do it, okay. So if you do it, what will you get? Okay, here 1 into 1 by Z, 1 to the power of 5 divided by Z to the power of 5 into Z to the power of 5 you will get. Okay, so and rearrange the equation. So you will get this particular thing, that is 5Z cube plus 3Z to the power of 4 plus 2Z cube plus 2Z to the power of square plus Z plus 1. That means what here? So here 5 is there. No, if you multiply this with Z to the power of 5, it will come here, Z to the power of 5. Next 3Z to the power of 4. Next in the reverse way it will come. The equation will come in the reverse way. Okay. So once you put this equal to 1 by Z, did you get this particular equation? All of you, please check it out. Please check this one whether you will get this or not. You'll get it right. See, once you get it, you please solve it. Okay, instead of yes, you take it z. You solve it the same process. Okay, when you solve the same process, you will find that sign changes. Okay, here two sign changes. That means for 3 2, the positive, negative, negative, positive sign changes is happening. So you can take this particular thing when the sign change is happening. It means that the roots are lying on the RHS. So when the roots are lying on RHS, we can say the system is unstable. Okay, we solved the numerical also. We understood the difficulty also. Is it clear? Take this one and leave.
Yes, sir.
Okay, all of you take this particular thing, and if you have taken this one, you can leave.
Yes, sir.